Hi everybody, this is Pranay and welcome to Vysh IAS. I hope you are doing great. So we are going to continue the Geography class 11th textbook, Fundamentals of Physical Geography. And before we start, I request you to please like this video and share with your friends. And please leave a comment on the video to let us know how you felt, and it will give us a lot of encouragement. And also please WhatsApp us, the number is here. Please WhatsApp us for any information or regarding the courses and the test series. And we shall start. So we are going to start with the landforms and their evolution, the chapter number 7. So this chapter is basically regarding different kind of landforms basically, which because of the geomorphic process, what kind of landforms are formed and how they are formed. Okay, several related landforms together make up landscapes. Okay, large tracts of earth surface. Each landform has its own physical shape, size, material, and is result of action of certain geomorphic process and agents. Action of most of the geomorphic process and agents are slow, and hence the result takes a long time to take shape. See, whatever the geomorphic processes happen, for the landscapes to become or the landforms to change their position in matter of shape, size and all, it takes a lot of time. It may take couple of years, it may take millions of years also. Okay? Every landform has a beginning. Landform once formed may change in their shape, size and nature slowly or fast due to continued action of geomorphic process. That we know. Due to the changes in climatic conditions and movements of land masses, either the intensity of processes or processes themselves might change, leading to new modifications in the landforms. Evolution here implies stages of transformation of either a part of the earth's surface from one landform into another, or transformation of individual landform after they are once formed. Okay, so what evolution is basically the stages of the transformation of some part of the earth or transformation of the landform into another basically. Okay, each and every landform has a history of development and changes through time. A landmass passes through stages of development, okay, comparable to the stages of life: youth, mature and old age. So any landmass goes through these steps. So when it starts, it is youth, and in the middle age it is mature, and at the end it is old age. Okay, we shall start with the running water. Okay, in humid regions which receive heavy rainfall, running water is considered the most important of the geomorphic agents. Okay, where there is heavy rainfall, running water is the most important geomorphic agent, okay, in bringing the degradation of the land surface. There are two components of running water. One is overland flow on general land surface as a sheet, as we know, like some sort of river kind of a thing. Another is linear flow as streams and rivers in the valleys. Okay, most of the erosional landforms made by running water are associated with vigorous and youthful rivers flowing over steep gradients. See, as we have read in the previous slide, there are three stages. Okay, in rivers also there are three stages. The youthful rivers, which which just recently got created, and in the starting stage, okay, the water flow is very fast. It breaks up the stones. The erosion is very high. The sediments are carried to very long distances. Okay. With time, stream channels over steep gradients turn gentler due to continued erosion, and as a consequence lose their velocity, facilitating active deposition. See, as it moves forward with the time, it gets slowed down at a point of time, because see, in the starting, for example, if you consider this some river, here in the starting stage, it is generated from here. Okay, when it is starting here, it is high in velocity. The velocity is very high. Okay, and at the end end of the river, the velocity is very low, it's very calm, and the sediments start settling up, and here the sediments start moving. Okay, this erosion and all happen in the initial stage. Okay, there may be depositional forms associated with streams flowing over steep slopes, but these phenomena will be on a small scale compared to those associated with the rivers flowing over medium to gentle slopes. The gentler the river channels is in gradient or slope, the greater is the deposition. The gentler the river channel, okay, the greater is the deposition. When the stream beds turn gentler due to continued erosion, downward cutting becomes less dominant, okay, and lateral erosion of banks increases, and as consequences the hills and valleys are reduced to plains. See, when as the time passes by, when the stream gets much more gentler, okay, because of continued erosion. See, for example, if this is moving in this way, because of the erosion, slowly this will start eroding up. Okay, and as the time passes by, it gets slowed down, and these deposits are settling down at the later stages, and because of this becomes a normal plain kind of an area. Okay, overland flow causes sheet erosion. Depending upon irregularities of the land surface, the overland flow may concentrate into narrow to wide paths. Okay, because of the shear friction of the column of flowing water, minor or major quantities of material from the surface of the land are removed in the direction of flow, and gradually small and narrow rills will form. See, when the water is flowing, for example, even if you make a small stream kind of a thing for your agriculture and all that, slowly when the water is flowing, a rill kind of a thing will be formed. Okay, small stream kind of a thing, and slowly the water will flow from it. Okay, these rills will gradually develop into long and wide gullies. After rills, it will form into gullies, and these gullies will form into valleys. Okay, deepen, widen, lengthen, and united give rise to a network of valleys. Okay, in the early stages, down cutting dominates, during which irregularities such as waterfalls and cascades will be removed. Okay, in the middle stage, streams cut their bed slower, and lateral erosion of valley side becomes severe. Okay, gradually the valley sides are reduced to lower and lower slopes. The divides between drainage basins are likewise lowered until they are almost completely flattened, leaving finally a lowland of faint relief with some low resistant remnants called monadnocks. Okay, monadnocks standing out here and there. So what happens is, when there is a flow, okay, for example, if there is a flow like this, once it gets normal, in the starting it will be in this direction. Once it gets normal, a piece of land, small pieces of land will be left alone, which is known as monadnocks. Okay, this type of plain forming as a result of stream erosion is called as peneplain, means almost plain. Okay, the characteristics of each of the stages of landscape developing in running water regimes may be summarized as follows. Youth stage. What is basically youth stage? In the initial stage, okay, streams are few during this stage with poor integration and flow over original slopes, showing shallow V-shaped valleys. V-shaped valleys you can see in the image. Okay, with no floodplains or with very narrow floodplains along the trunk streams. Okay, streams divided are broad and flat with marshes, swamps and lakes. Meanders, if present, develop over these broad upland surfaces. Okay, these meanders may eventually entrench themselves into uplands. Waterfalls and rapids may exist. Waterfalls and rapids may exist where local hard rocks bodies are exposed. Okay, so waterfalls and rapids will be existing. There are possibilities. Okay, in the mature stage, streams are plenty with good integration. Okay, so there are plenty of streams with good integration. In the youth stage, there was a poor integration. Okay, the valleys are still V-shaped but deep. Okay, the deepness has increased. See here, the deepness is not that great, but in this the deepness has increased. Okay, trunk streams are broad enough to have wider floodplains. Obviously you can see, okay, within which streams may flow in meanders confined within the valley. Okay, the flat and broad interstream areas and swamps and marshes of youth disappear and stream divided turn sharp. Okay, waterfalls and rapids disappear. Okay, in the youth they may be present, but in mature stage they disappear. Okay, and in the old stage, small tributaries during old stage are few with gentle gradients. Okay, stream meander freely over vast floodplains showing natural leaves, oxbow lakes, etc. What are these? You will see in the coming slides. Divides are broad and flat with lake, swamps and marshes. Most of the landscape is at or slightly above the sea level. More or less it is nearby the sea level. There is no very deep kind of movement. Okay, see here, for example, the youth more or less is in the straight line. In maturity it starts meandering. Okay, here see, you see the V-shaped cross section, and here the it is broader. The V-shaped is broader basically, and in the old age it is more or less flat. Okay, it is more or less flat. Okay, and in the old age it forms the oxbow lakes. Okay, and the meanders is also very high. Okay, we will see about the erosional landforms. Okay, valleys start as small as narrow rills. Okay, as small as narrow rills. Okay, the rills will gradually develop into long and wide gullies. The gullies will further deepen, widen, and see here, these are valleys. This is a valley. Okay, before valley there will be some kind of rill, small small pathway of water. Okay, rill will form into gully, gully will form into valley. Okay, depending upon dimensions and shapes, many type of valleys like V-shaped valley, gorge, canyon, etc. can be recognized. See here, this is a gorge. When the depth increases, see here how deep it is, here, and in canyon how deep it is. Okay, you will be able to understand if the water is flowing for a couple of years. For example, if we consider some 1,000 years, okay, because of the erosional factors, this thing will go much more deeper. Okay, which will form gorge, and which will with course of time, because of the erosion and all that, will form the canyons. Okay, and canyons, you see how deep they are, how the steepness has increased and how deep they are. Okay, the gorge is a deep valley with very steep to straight sides, and a canyon is characterized by steep step-like side slopes and maybe as deep as a gorge. Gorge is almost equal in width and at its top as well as its bottom. Okay, in contrast, a canyon is wider at its top than its bottom. In fact, a canyon is a variant of a gorge. Okay? See here, what they are saying is basically the mouth and the end. Okay, if you consider the cross-sectional way, for example, if it is moving like this, this is the top layer and this is the bottom layer. Okay, if you consider this, this will be more or less same. Okay, this thing and the down layer will be more or less the same, but in the canyon what they say is this may be much more wider than this thing, and in valleys obviously this is very wide and this thing is very small comparatively. Okay, valley types depend upon type and structure of the rocks in which they form. For example, canyons commonly form in horizontal bedded sedimentary rocks and gorges form in hard rocks. Okay, so canyons form in horizontal bedded sedimentary rocks and gorges form in hard rocks basically. Okay, next comes the potholes and plunge pools, because see, for example, if you have seen the experiment of water, we have discussed in the last class also, you just hit on the YouTube and search water's effect on the stone. The Chinese experiment is there. A stone will be there, the water will be falling. For first 10 or 15 years, there will be no any depression on this. But couple of years later, slowly small holes will be formed on this. Okay, and after a couple of years, because of the movement of the water and the depressions being formed and the circular rotation of the material in this, a huge hole will be forming basically. Okay, these are called as potholes and plunge pools. What are they exactly? You will see in this slide. Okay, over the rocky beds of hill streams, more or less circular depressions called potholes form because of stream erosion aided by abrasion of rock fragments. Okay, once a small and shallow depression forms, pebbles and boulders get collected in those depressions and get rotated by flowing water, and consequently depressions grow in dimension as it is falling, and also it is carrying some sort of sediments, rocks and all, and because of that hitting in those small holes, it is creating the holes into a bigger thing. Okay, a series of such depressions eventually join and stream valleys gets deepened. Okay, at the foot of waterfalls also, large potholes, quite deep and wide, form because of the sheer impact of water and rotation of the boulders. Such holes are called as plunge pools. See, this is potholes. Okay, these are potholes and these are plunge pools. Okay, you see how deep they are. Okay, and see here they are small and very smallly divided. You can see these kind of things nearby these small waterfalls and all. And when in larger waterfalls, when the water is flowing for a couple of years, it will take a lot of time, and this will start eroding and more or less will look like this. Okay, these are much deeper and larger. Okay, these are called as plunge pools. So incised or entrenched meanders. So what is exactly meanders? Meanders is basically this kind of flow is there, right? This kind of flow of river is basically called as meanders. Okay, see, the river is flowing like this. Okay, this movement is said to be called as meanders. It will move like something like this. Okay, so in this meanders also there are a couple of parts which we will see in the next class basically. Okay, in the next slides. In streams that flow rapidly over steep gradients, normally erosion is concentrated on the bottom of the stream channel. Okay, also in the case of steep gradient streams, lateral erosion on the sides of valleys is not much when compared to streams flowing on low and gentle slopes. Because of active lateral erosion, stream flowing over gentle slopes develop sinuous or meandering courses. Okay, it is common to find meandering courses over floodplains and delta plains where stream gradients are very gentle. Okay, but very deep and wide meanders can also be found cut in hard rocks. Such meanders are called as incised or entrenched meanders. See, this is a meander basically. Okay, I will show. Wait. See, this is a meander, what we call. When this is cutting a hard rock, it is called as incised meander. Okay. See, this is basically a meandering river. Okay, this is flowing in this way, basically this way. Okay, the course, the course of a change in the course basically is called as the meanderness, this movement like this. Okay, this is entrenched meanders. You can see how this hard rock is being cutted down slowly. Okay, so this kind of river is called this kind of meander is called as incised or entrenched meander. Okay, we will see about the river terraces. River terraces are surfaces marking old valley floor or floodplain levels. They may be bedrock surfaces without any alluvial cover or alluvial terraces consisting of stream deposits. River terraces are basically products of erosion as they result due to vertical erosion by the stream into its own depositional floodplain. You can see the movement here. The movement like this. See, it is, because of the erosion. See here you can see, here you can see, here you can see. Okay, this is known as river terraces. There can be a number of such terraces at different heights, indicating former river bed levels. See, maybe in the previous stage the water was at this level, later it changed to this level. Okay, because of that itself these river terraces are forming basically. Okay, the river terraces may occur at same elevation on either side of the rivers, in which case they are called as paired terraces. For example, if this and this level is same, or this level and this level is same, it is called as paired terrace. Okay, next we will see about the depositional landforms. Alluvial fans. What are alluvial fans? See, when the sediments are being carried, the sediments are being deposited also at a point of time, and because the sediments, the softer sediments get deposited at the mouth of the river, specifically when it is coming from a height, okay, it will form into a fan kind of a shape. Okay, you can see this fan kind of a shape. You can see in this image here a small fan kind of a shape is being formed because of the sedimental deposits. Okay, and because of this fan kind of a shape, it is called as an alluvial fan. Alluvial fans are formed when streams flowing from higher levels, okay, from a height basically, break into foot slope plains of low gradient. Normally very coarse load is carried by streams flowing over mountain slopes. Okay, because of the because of the steep, the velocity of the water increases, which tends to carry much coarser material. Okay, this load becomes too heavy for the streams to be carried over gentler gradients. Okay, because of the velocity here, it will carry, but when you just get into a normal plane, obviously it doesn't has the velocity to carry the sediments basically, so it dumps it when it reaches this plane basically. So here this slowly gets deposited and it gets into a fan kind of a shape like this. Okay, and spread as broad low to high cone shaped deposits called alluvial fan. Usually the streams which flow over fans are not confined to their original channels for long and shift their positions across the fan, forming many channels called as distributaries. Okay, alluvial fans in humid areas show normally low cones with gentle slope from head to toe, and they appear as high cones with steep slope in arid and semi-arid climates. Okay, see here this steep slope is there because of the the slope and the velocity of the water. It was much more faster at this point of time, but as soon as it reaches the end, the mouth, automatically it gets slower, and because of the deposit, it becomes like a fan kind of a shape. So it is called as alluvial plain. Next is called delta. Delta are like alluvial fans only, but develop at a different location. Okay, since alluvial fans were because of the height. Okay, because of the height, the load carried by the rivers is dumped and spread into the sea. Okay, if this load is not carried away far into the sea or distributed along the coast, it spreads and accumulates as a low cone. Unlike in alluvial fan, the deposit making up deltas are very well sorted with clear stratification. Okay, the coarsest material settle out first, and the finer fractions like silt and clay are carried out into the sea. As the delta grows, the river distributary continues to increase in length, and delta continues to build up in the sea. So what is happening is, because of the sediments, they get settled. The coarser material gets settled near the coast. If this is coast, the coarser material will settle here. The finer material will start moving, and slowly this is kind of the coast is slowly extending kind of a thing. Basically, see, you see this small image. See, as the time is passing, okay, slowly because of the sediments, there is some sort of expansion kind of a thing happening. You see, okay, And in this also the river will be having a lot of small tributaries and distributaries, and it will slowly the what do we call, the land is slowly expanding with the time. Okay, so the delta looks somewhat like this in the aerial view. So here the river is here, and slowly it is depositing, and because of the deposit it will increase the size also. Okay, next comes the floodplains, natural leaves and point bars. Deposition develops a floodplain just as erosion makes valleys. See, what happens is, when the deposition is there, okay, it will form a small flat surface kind of a thing. Okay, floodplain is a major landform of river deposition. Large size materials are deposited first when stream channel breaks into a gentle slope. Okay, thus normally fine sized materials like sand, silt, clay are carried by relatively slow moving waters in gentler channels, usually found in the plains, and deposited over the bed, and when the water spills over the banks during the flooding above the bed. Basically, a river bed made of river deposits is the active floodplain. See, the deposits are getting settled here. Okay, and after the river, maybe it changes its course, or maybe it dries up, or whatever it is, because of the sediments it becomes a very flat surface which is known as floodplain. Basic funda is that thing. Okay, the floodplain above the bank is inactive floodplain. Okay, inactive floodplain above the bank basically contains two types of deposits: flood deposits and channel deposits. Okay, this is a prime example of the floodplain. You can see. Okay, in plains, channels shift laterally and change their courses, occasionally leaving cut-off courses which get filled up gradually. Okay, such areas over floodplains built up by abandoned or cut-off channels contain coarse deposits. Okay, the flood deposits of the spilled water carry relatively finer material like silt and clay. The floodplains in a delta are called as delta plains. Okay, natural leaves and point bars are some of the most important landforms found associated with floodplains. For example, if you see when there is a meander kind of a thing, okay, here because of the water pressure, automatically the land will be a little higher. You will see in the images. I am not able to draw properly. You will see in the coming images. Okay, natural leaves are found along the banks of large rivers. They are low, linear and parallel ridges of coarse deposits along the banks of rivers, quite often cut into individual mounds. Okay, point bars are also known as meander bars. Here, when the meander is there, this part is much higher basically. And this is, this concave part is basically, concave side of the meander is basically known as the point bar, which you will see in the coming slide. They are found on the concave side of meander of large rivers and are sediments deposited in a linear fashion by flowing water along the bank. Okay, they are almost uniform in profile and width and contain mixed sizes of sediments. See here, this is a natural leaf. You can see on the either sides, it will be some sort of a kind of the depositions. Because of the depositions, it will be having a higher level kind of a thing. Okay, so here you see, here before normally the water was flowing. Okay, during the flooding the deposits got deposited at this point of time here, and after flood gets dried up or just moves up, this deposition will leave like this itself. Okay, this is known as natural leave basically. Okay, and here you in the meander basically this is known as point bar deposit. Okay, meander. What is meander? Basically, we saw the river is flowing like this, which is known as meander. Okay, in large flood and delta plains, rivers rarely flow in straight courses. Okay, loop-like channel patterns called meanders develop over flood and delta plains. Okay, meander is not a landform, but is only a type of channel pattern. Okay, this is because prosperity of water flowing over very gentle gradients to work laterally on the banks, consolidated nature of alluvial deposits, making up the banks with many irregularities, which can be used by water exerting pressure laterally and Coriolis force acting on the fluid water. Okay, when the gradient of the channel becomes extremely low, water flows leisurely and starts working laterally. See, this is the actual course of the river. But what happens because of the three, these things, it will start flowing in this way. Okay. Slight irregularities along the banks slowly get transformed into small curvature in the banks. The curvature deepens due to the deposition on the sides of the curve. Okay, so whatever, so for example, if this is river, okay, so here because of the depositions, if it is flowing like this, okay, here the sediments will start depositing because of the change, and because here the sediments are there, the water will hit and move in this side. Okay, here it will move, and here some deposits it will start forming, and automatically it will start forming into this side. Okay, if there is no deposition and no erosion or undercutting, the tendency to meander is reduced. Okay, automatically the meander will also get into normal path. Basically, normally in meanders of large rivers, there is active deposition along the concave bank and undercutting along the convex bank. Okay, the concave bank is known as cutoff bank, which we saw here. Okay, see, cutoff bank. Okay, here it is moving this side. Okay, which is known as the cutoff bank basically. Okay, basically the position where the meander is happening. Okay, which shows up as steep scrape, and the convex bank represents a long gentle profile. As meanders grow into deep loops, the same may get cut off due to erosion at the infection points and are left as oxbow lakes. See here the water might be like this. It was flowing in this way, but because of the cutoff, it started moving in this way, and slowly the link between this river and this part of the river gets cut down, and this part is called as oxbow lake. Okay, see here is the infection point. Here the water was moving actually in this way, and because of the cut down, it started moving in this way, and slowly this part got dried up or cut down by the river, and this is known as the oxbow lake. Okay, what is next is the groundwater, and groundwater has one of the major roles in the landforms. Okay, because of the groundwater, the limestone part of the land gets dissolved, and lot of things happen. Okay, we will see in this slides. Here the interest is not on groundwater as a resource. Our focus is on the work of groundwater in erosion of land masses and evolution of landforms. Okay, the surface water percolates well when the rocks are permeable, thinly bedded, and highly jointed and cracks. See, when for example, if it is consider this as ground, if it is a solid rock without any permeability, will the water go inside? No. But when there is permeability and also there are couple of cracks in it, okay, and it is thinly bedded, okay, here small rock is there, here small rock is there, here small rock is there, automatically the water will move downwards. Okay, after vertically going down to some depth, the water under the ground flows horizontally through the bedding planes. The water will move horizontally. Okay, bedding planes, joints, or through the material themselves. It is this downward and horizontal movement of the water which causes the rocks to erode. Okay, because of this only the erosion of the rocks happen. Physical or mechanical removal of materials by moving groundwater is insignificant in developing landforms. That is why the result of the work of groundwater cannot be seen in all type of rocks. But in rocks like limestones or dolomites rich in calcium carbonate, the surface water as well as groundwater through the chemical process of solution and precipitation deposition develops variety of landforms. In the specifically in the limestone and dolomite, because there is a reaction of the water on the calcium carbonate, it slowly gets dissolved in water basically. So automatically the hard content gets dissolved, okay, and because of that there will be a lot of changes in the landform. Okay, these two processes of solution and precipitation are active in the limestones or dolomites, occurring either exclusively or interbedded with other rocks. Okay, any limestone or dolomite region showing typical landform produced by the action of groundwater through the process of solution and deposition is called as karst topography. Okay, after the typical topography developed in limestone rocks of karst region in the Balkans adjacent to Adriatic Sea. Okay, the karst topography is also characterized by erosional and depositional landforms. So we will see into it the karst topography, erosional landform. Okay, so pools, sinkholes, lapis, and limestone pavements. What exactly it is? When when there is a limestone part, for example, here there is a huge part of limestone, and here small depression is there where the water got settled, and here slowly it gets starting dissolving. Okay, it starts dissolving here, and slowly there is there is some sort of depression here. Okay, this depression is called as a pool basically. Okay, swallow holes. Small to medium sized round to sub-rounded shallow depressions called swallow holes form on the surface of limestone through solution. Okay, this looks something like this. Okay, sinkholes are very common in limestone or karst areas. A sinkhole is an opening more or less circular at the top and funnel shaped towards the bottom, with the sizes varying in area from meters to hectare, with the depth from a less than half a meter to 30 meters or more. This is one of the example. Okay, it gives some sort of a funnel kind of a shape. Here you can see. Okay, so sinkhole looks something like this. It gets much more deeper as well as much more steep. Okay, after some time, here the water starts percolating inside. You see some, because of the cracks and the movements and all, in this part of the limestone gets dissolved. Because of this sudden breaking of thing happen, and here it is called as collapsing basically. Okay, some of these form solely through solution action, solution sinks, and others might start as solution forms first, and if the bottom of the sinkholes form the roof of a void or a cave underground, it might collapse, leaving a large hole opening into a cave or void below. Okay, an empty space. Okay, quite often sinkholes are covered up with soil mantle and appear as shallow water pools. Okay, it looks something like quicksand, what we call daldal in Hindi. When you move on it, you just get inside. Okay, anybody stepping over such pools would go down, like it happens in the quicksands in desert. Obviously, because the place is basically hollow. Okay, because of the soil mantle which is covering it up, it looks like there is something shallow water pool kind of a thing. But when you just step it on it, you will just move inside slowly. Okay, the term doline is sometimes used to refer the collapsings. Okay, solution sinks are more common than collapsings. Solution sinks are more common than the collapsings. Just a second. Okay. Next, when sinkholes and dolines join together, okay, sinkholes and dolines, the collapsings, join together because of slumping of materials along their margins or due to roof collapse of caves, long, narrow to wider trenches called valley sinks or Wallace form. Okay, Wallace looks something like this huge. Okay. Gradually, most of the surface of limestone is eaten away by these pits and trenches, leaving it extremely irregular with maze of points, grooves or ridges or lapis, which does look like this. This is one of the lapis. Okay, especially these ridges or lapis formed due to differential solution activity, differences in the activity along parallel to subparallel joints. The lapi field may eventually turn into somewhat smooth limestone pavements after some time, because again there is some sort of action on this of the solution. It will slowly melt up and it will form like limestone pavements. Okay, next are caves, the limestone caves. In areas where there are alternating beds of rocks, shales, sandstones, quartzites with limestone or dolomites in between, where shale and see, for example, there is a shale and slowly there is a limestone and again there is a shale. What happens, because of the solution and all, this limestone will get dissolved. Okay, and this dissolved part will be empty or hollow, where their cave kind of a thing gets formed. Okay, water percolates down either through the materials or through cracks and joints and moves horizontally along bedding planes. Okay, it along these bedding planes that the limestone dissolves and long and narrow to wide gaps called as cave result. Okay, there can be a maze of caves at different elevations depending upon the limestone beds and intervening rocks. Caves normally have an opening through which cave streams are discharged. Caves having openings at both the ends are called as tunnels. Okay, see here. Here the water moved from here and slowly it ate up the lime, and this part of is known as stalagmite, and this is also cave mouth. Okay, from where the discharge happens, and this thing is being supported by this thing which is called as a pillar, and the upper part, which are the sharper edges, which are just dripping down kind of you can see in the snow basically, right? So these are called as stalactites. See here, these are stalactites, you can see. Okay, the sharper things, and the down thing is called as stalagmite. Okay, these things. Okay, so we will see about the depositional landforms. Many depositional forms develop within the limestone caves. The chief chemical in limestone is calcium carbonate, as we know, which is easily soluble in carbonated water. Okay, this calcium carbonate is deposited when the water carrying it in solution evaporates. At a point of time, see this limestone, till now we saw it is getting dissolved and it is moving. But at a point of time it will go and evaporate also somewhere. Okay, and there it forms some sort of rough rock surface. Okay, so stalactite, stalagmites and pillars, which we saw in the cave thing, those form because of the evaporation basically. Stalactites hang as icicles of different diameters. Normally they are broad at their bases and taper towards the free end, showing up in the variety of form. See, they will be something like this. Okay, they are broader and sharper at the edge. Okay, stalagmites rise up from the floor. It will be something like this. Okay, in fact stalagmites form due to dripping water from the surface or through the thin pipe of the stalactite immediately below it. Okay, so because of the water it is flowing, it will form this thing. Stalagmites may take the shape of a column, a disc with either a smooth rounded bulging end or a miniature crater. Stalactites and stalagmites in limestone caves depression. The stalagmite and stalactite eventually fuse to give rise to columns and pillars of different diameters. Okay, so see, this is column or what we call a pillar basically. Okay, so these are stalagmites, and because of the dripping, this will form the stalagmite from the stalactite. Okay, so next comes the glacier. Okay, masses of ice moving as sheets over the land. Continental glacier or Piedmont glacier is a vast sheet of ice spread over the plains at the foot of mountains basically, or as linear flows down the slopes of mountains in broad trough-like valleys. Mountain and valley glaciers are called as glaciers. Basically it is moving ice sheet, or consider it as a huge river kind of a thing of ice basically. The movement of glacier is slow, unlike water flow. Okay, the movement could be a few centimeters to a few meters a day, or even less or more. Okay, glaciers move basically because of the force of gravity. Here is one of the example, and lot of glaciers are there in India also. You can consider saying those as examples. Okay. Erosion by glacier is tremendous because of the friction caused by sheer weight of the ice. Because of the ice weight, there is lot of friction, more than the water basically. The material plunged from the land by glaciers, usually large sized angular blocks and fragments, get dragged along the floors or sides of the valleys and cause great damage through abrasion and plucking. When it is moving, for example, the glacier is moving in this way, huge stones will be carried with this. Okay, glaciers can cause significant damage to even unweathered weathered rocks and cause reduce high mountains into low hills and plains. Okay, as glaciers continue to move, debris gets removed, divides gets lowered, and eventually the slope is reduced to such an extent that glaciers will stop moving, leaving only a mass of low hills and vast outwash plains along with other depositional feature. Okay, for example, I will show you. See, for example, the glacier was moving in this way. Okay, because of the heavy weight. Okay, because of the heavy weight, this will carry huge parts of the rock with this. Automatically what it is having is, this thing will move with the glacier, right? So automatically the height of the cliff or the mountain gets reduced automatically. Okay, and this will become low hills or vast outwash plains. Okay, so that was all for today, and I hope you find the class useful. I hope you will like the video and comment, please let us know how you felt at least, and we will try to change if anything is needed. And please share it with your friends and subscribe to the channel. And that's all for today. Thank you and have a great day.